different programs, we can make our robot go forward, reverse,
Now we're going to make our robot turn. Well, we have 3 different turns: point turn, left turn, and swing turn. Each of them may sound the same, but they are different.
Here's swing turn.
As you saw how it swung, here is how the wheels work.
Only the right wheel turns, causing it to turn left. Now, in left turn, the robot pretty much does the same thing, except it goes the opposite way. And in it, the left wheel moves, causing it to turn right.
Now on to point turn. See how it swung completely different than the other two? Well, if you take a look at the wheels, they're both moving.
But in opposite directions.
They both swung at the same time, but just in the opposite direction. Okay, so to make our robot move forward, backwards, and to turn, we found out about this website called LEGO Mindstorms Education NXT. And what we did here was we used these special videos to help us build our robot. Then we use these blocks. See, the first block right here runs motor C, so one motor, and it runs it forward. The second block runs the other motor, motor B, and it still runs it forward. So then we change the rotation sensor to 720 degrees. That's how many degrees the wheels would turn. And then these 2 blocks right here tell the motors to both stop. And that's for the robot to go forward. For backwards or reverse, it's the same thing like forward except opposite. We're telling these 2 motors, motor C and B, to go backwards instead of forward. Again, the wheels turn 720 degrees, and these 2 tell the motors to stop. Now onto the tricky parts. Swing turn. Motor C here, as you can see, it has an arrow to go forward. Motor B, there's no arrow, so it's telling it to stop. This is a wait for block, and it tells us the wheels go 720 degrees forward. And then these 2 right here tell the motors to stop. And this needs to go back there. Okay. Now for left turn, it's like swing turn except opposite. Tells motor C to stop, motor B to go forward, wait for block 720 degrees, and then these 2 tell the motors to stop. Point turn. Here is a tricky one. If you look, both of these have the arrows going. There's no stop. But if you look closely, the arrows are the opposite direction. Motor C goes forward, or up in this case. Motor B goes backwards, down. The wait for block, still 720 degrees. And then these 2, of course we need them, tell them to stop. how do we get this to our robot, you may ask? Well, we go down here, and then we use a USB cord and download it to our robot. And then, voila!
To figure out how to do these programs, we go to Lego Mindstorms, which is a site that has videos that show us how the programs are supposed to look like and what the robot is supposed to do.
Now, on to our next step. Now on to measured turns. Please excuse our special drawings.
For measured turns, we want to find the circumference of our circle and see how many degrees we need to make the wheels turn to make the robot turn a full 90 degrees. So, you're going to have to connect a marker to the farthest back point away from the inside and set your robot to go on the line. We've already drawn our circle, so we're just going to have our robot run along the line to show you guys how it's done. You may need to press the go button more than a couple of times. So now, first, to find out the circumference, you have to draw your chords, and then you get a piece of string, like so, and you put your marker in it, and you go on each end of the cord to make 2 X's. For each cord. Now, you go from the inside of the cord of each one, and you trace it with the ruler to the cord, to wherever it goes. And you do that for each cord. I call these things a cord.
Now, if you look, we have the center of our circle. Yay!
From where the lines from the arcs cross. Right there.
Christine, what is the diameter of that circle?
Well, let's see. It is approximately we're missing half of our ruler. So, it's about 11.5 inches for our diameter. Okay, now, since our diameter is 11.5 inches, and to get the circumference, you take pi times diameter, we'll take 11.5 times 3.14 for pi. Do your math.
At least we have someone good in math.
And then you round to the 100th decimal point. So then your circumference is 36.1.
Do I go to camera?
It's working and it's recording.
What?